Hello everyone, good afternoon from India. I hope you're doing well. Can I get a thumbs up? All right, great. So, welcome to this session on machine learning and computer vision as well as Gen AI. My name is Nitin Tiwari. I'll be a speaker for today's session on machine learning. So, I hope you are excited for this. All right, that's great. So, okay, before we begin, can just someone tell me what is your understanding about machine learning and like whatever you know about this? Is this your first time? Are you a beginner or you have any prior experience with ML? You can just unmute yourself, or if you're not comfortable with that, then you can just put in the chat. Anyone here would like to try? Great, beginners. Okay, so for those like who are beginners in ML, have you heard about what is machine learning or any understanding about that? Just wanted to know. Okay, so Ali Ahmed says that he knows about ML. Amna Khan says that she has heard about it. Okay, great. Okay, might be related with training AI models. That's true. Okay, learning from past experiences. That's correct. Pretty good responses in the chat. ML is about teaching machine how to do certain tasks without human intervention. That's true. Okay. Great. All right. So yeah, that's pretty much correct. That's what I was expecting. So even if you're a beginner or if you don't have any prior experience with machine learning, okay, Abdul has tried a project with Google Teachable Machine with TF Lite. Fantastic. A lot of mathematics is involved. All right. Thank you so much for the responses. So yeah, you are correct in your sense that ML is about teaching the machines to learn just like we as humans do. Like there's some algorithms that needs to be, implemented. So yeah, so in this session we'll be learning about what exactly is machine learning. So even if you're a beginner, then you don't need to worry about that. I'll cover all the basic fundamentals for you so that you get to know what exactly machine learning is, how you can use it in your day-to-day applications. So if you are, thinking to pursue ML as a career, or let's say it's your, region of interest or a domain of interest, then you can, just dive deeper into that after the session. And we'll be covering a lot of examples today based on computer vision, how to use TensorFlow, as well as generative AI as well. So without doing any further ado, let's begin with the session. And yeah, I'll share my screen. So please give me a thumbs up once you can see my screen, and then we can just move ahead. All right. Okay, so welcome again to this session. My name is Nitin Tiwari. I am a software engineer at LTI Mindtree and a Google developer expert in machine learning. I'll be your speaker for today's session. Let me just close this application running in the background. All right. So just a bit about myself. I'm a software engineer at LTI Mindtree and a GD in ML. I'm also a technical speaker, and I had the opportunity to give more than 30 talks across India and Southeast Asia. Last year, I was in Indonesia as well as Uzbekistan. Apart from that, I'm a contributor to Google Dev Library. So if you're not aware of what is this Google Dev Library, it's basically an open source project by Google where developers across different parts of the world come together and they contribute to this library. This is basically a repository of projects or open source projects that you do in different domains like ML, Android, web, and cloud, etc. So I've been contributing to this. Some of my projects and blogs are published there, so you can just check it out later. And apart from that, I am also a technical writer. So I've published few blogs on ML as well as their applications on Medium. So I'll be sharing the links at the end of the session, so you can just check them, and you can follow me there as well to get updated with the latest trends and technologies in ML. But for now, let's try to understand what we'll be covering today. So we'll just have a quick overview of what is machine learning, followed by types of learning like supervised learning, unsupervised learning. We'll understand what is neural network, followed by what is TensorFlow. So I hope you have heard about this TensorFlow, right? We are in TensorFlow user group Islamabad. So TensorFlow is basically a library of ML which we can use to create some ML applications. So we'll see what is TensorFlow, followed by some examples. Then we have some examples on computer vision as well. So we'll be going through that. And at the end of the session, I'll be also covering this Gemini since we are in a buzz of generative AI right now, LMs and all those stuff. So it's important for us to know what exactly is happening in the world right now. So I'll just show you a quick overview of what is Gemini, followed by some hands-on examples. So you can also just experience that yourself. And then finally, if you're a beginner or an intermediate, depending upon your expertise, I'll have some resources for you to get started. So you can just check them out. So again, let me just clarify one thing. So if you have any queries or questions, don't hesitate in asking. Just unmute yourself or just put in the chat. I'll be glad to help you with those questions. And yeah, so just sit back and relax and enjoy for the next 1 hour for this. So okay. So many of you answered very well that machine learning is basically, teaching the machines with some set of data. Like we provide that data to the machine, and then we expect the machine to learn from that, from the past experiences. Some of you answered that in the chat. So that's pretty true. But just to put it in one line, let's say, we are humans, right? So when we were 4 years or 3 years old, we were taught that A for apple, B for ball, and so on. So basically, we were shown an object and we were told that this is called an apple because this is red in color, it's round in shape, and all those stuff. So similarly, we do the same thing with the machines as well. So instead of explicitly programming that, what do you mean by explicitly programming? It means that you provide the data to the machine, you provide the rules, and then we get the answer in return. So for example, if you provide 2 and 3 and you ask the machine to do an addition, it will give the result as 5. So we are explicitly telling the machine to do the addition, right? So every time we have to change the operation. Let's say if I want to do subtraction or multiplication or any other operation on that. So in that case, I'll have to again and again tell the machine that I need to do this. But what happens in ML? You just provide the data and you provide this. This is the answer that I'm expecting. So you do whatever you want to do, like whether you want to do addition, subtraction, multiplication. I don't care. I want this answer if I'm providing this as an input. So this is basically just an overview of what is machine learning. We just provide the data and the answers. The machine learns from the patterns, like what data was provided. So if I'm providing you 2 and 3, and if the answer expected is 5, of course you will think that subtraction will not work in this place, right? We'll have to do the addition between the two numbers. So that's how the machine learns based on the patterns from the data it receives. And then finally it gives the rule. So this is how machine learning is about, like in just simple words, but it's more complex than what we see in this particular slide. So we'll try to see some examples. Okay. Uh, all right. So this is supervised learning. There are different types of machine learning, like algorithms. We call it as supervised learning, unsupervised learning, reinforcement learning, and so on. But let's try to understand supervised learning right now. So as the name suggests, supervised is nothing but we explicitly tell the machine that, like, we teach the machine by showing it some data. Okay, by providing the data as well as some labels or some, what output I'm expecting with respect to that. So we already provide that data or that information to the machine. And once the machine learns from it, then we provide it some test data or some data which it hasn't seen previously and then expect it to give the correct results. So for example, the image that you see here, at the left hand side, I'm providing the machine the image of an apple. Of course, if someone asks us how an apple looks like, it's red in color, it's like it's round in shape. So those are the features of an apple, right? And then we also tell the machine that this is an apple. So not just we are providing the data, but also telling that what object this is. Okay. So again, I'll have an example. So this is a water bottle I have in my hand. So I tell the machine that this is a bottle. So next time if I show you some object which is similar in this shape, then you should answer that this is a bottle, right? So that's how the machine learns from the features. And next time when like once the model is trained, when we want the machine to uh, give the results based on data it hasn't seen before, that's nothing but just evaluating the model. So you see the difference between these two images. When I was training the model, I provided the image of the apple which is red in color, but we also have different varieties of apple which are like green in color and other features, right? So we don't normally get to see green apples. So in that case, the machine might, go wrong somewhere. Let's say it has classified this apple as a pear, but the confidence is 30%. So it still has, correctly classified or labeled this object as an apple. So this can happen. Okay, so if there is a variety in your data set, then that's pretty good when we train the model, because in such cases the model is also able to identify that these are the variations in the data. So if you just provide a skewed data to the machine, then it will not be learning if you provide some new data. So this is like similar to what we learn during our childhood. If we are taught something, we just remember it for lifetime, and then we try to implement all the stuff. But if we are not shown anything in the childhood itself, then we never learn from that. Similarly to this, we just provide the data to the machine and the label, and then test the model on some new data. So I hope this is clear to you. If you have any queries or questions so far, then just let me know. Otherwise, we can just move ahead with unsupervised learning. But before that, we have some different types of data as well. So if you are trying to learn machine learning, and if you are trying to move into this field, it's important to understand data. So ML is not just about training the model. The overall thing here that matters is what data you are working on. Okay, so let me classify the data that we see around us. So you might have worked with Excel sheets, right? Excel sheets and images, videos, and whatnot in your like software engineering or during your jobs. Or if you're a student right now, then you might have heard like worked with these assignments, right? Working with CSV files, Excel sheets, and so on. So when we talk about structured data, so structured data is basically the data which is in some particular format, which can be CSVs or JSON files or Excel sheets or databases, etc. Okay, so there is a particular format. This is an organized data. You'll see some rows and columns, right? So this is structured data. But when we talk about unstructured data, it can be in the form of images, videos, emails. There is no specific format, right? So one email can have a subject tag. Some people try like miss putting the subject in the email when they try to send the emails. Then all those stuff, right? So in unstructured data, the format is not organized. Okay, there is no definite format. It can change from one thing to another. So, for example, if you have posted something on LinkedIn or Twitter, you'll see that there is a you have the option to put the caption, you have the option to put the comments, to put a post. The post can be image or video. So there is no specific format to that. So that's called as the unstructured data. And when we deal with ML, we have to be very careful which algorithms to choose and which ones not to choose. So this all depends upon the data that you're dealing with. So let's have an example of supervised learning on unstructured data. Okay. So supervised learning on structured data mainly deals with the two categories. First is the regression and second is the classification. So I'll give you a classic example of ML. So every ML learner always goes through this example. Let's say you have a plot somewhere. Okay. You want to buy some home or some land, and you go through the history of that particular area. What was the selling price? What is the locality of that particular region? Is it in the middle of the city? So if it is in the middle of the city, then it will be costly, of course. If it is in a remote place, which is, like, for example, which is a village or something like that, the cost will be down, and facilities around that particular region. So you go through all the history data, and then you try to purchase those land or house depending upon that. So when you try to predict a value, that the value of this particular house after 5 years or after 3 years, or let's say after 2 years, it will be this particular value. So that is nothing but regression, where you're trying to predict a value. So regression is basically some numbers. Okay. So that is called as regression in supervised learning. But let's say if you want to classify something. So the example that we saw earlier, it can either classify this image as an apple or a pear. So this is called as binary classification when the classes is two, like the number of classes we are dealing with is two. Okay. So again, like let's say you have given some exam and your results are out. So you can either pass in the exam or fail in the exam. There is no other thing in between, right? So that is called as classification. Okay. And depending upon the number of classes, we can have binary classification, multi-classification, and so on. So if the number of classes is two, then that is binary classification. If the number of classes is greater than equal to three, that is called as multi-classification. So just for your understanding, okay. So I have one good example for you to understand what is supervised learning on unstructured data. So in the previous slide, we saw that this was on structured data. Okay, so the examples that you see on this slide, this can be for CSV files or Excel sheets or JSON files, depending upon some organized data. But when we talk about images, so the images and videos are not structured; these are unstructured. So I hope you have seen this cartoon in your childhood, one of my favorites still. Okay, so this is an example of image classification where you just provide the image of the cartoon. Okay, this is a cartoon classifier that I had built a couple of years ago. Okay, so what it is doing is we are uploading the image from the gallery and the ML model is running on this. Some of you also mentioned that you used teachable machine. So this example was made with the help of that. And we are trying to identify the content in this image. So this is an example of multi-classification where you see there are five classes, like five different types of cartoon, and depending upon which one is the most accurate one, it is giving the results. So that's how supervised learning works on unstructured data. This is just an example, image classification as well as object detection. So like there are many algorithms for different tasks, and this is just one of them. So I hope this is clear to you. Now let's try to understand supervised learning on unstructured data. So this example that we saw was for computer vision. And yeah, just for your understanding, if you are not aware of what computer vision is, so when you deal with data which is in the form of images and videos, specifically images and videos, okay, that we call it as computer vision. So just like we as humans see that this is a mobile phone, right? We also try to teach the machine that this is a particular object that you need to understand. So based from the content or based from the features that the image has, the computer learns from it. It has a vision just like us, so that's why we call it as computer vision. And if the data is in the form of text or audios, so you might have used this chat GPT and all those stuff, right? Gemini, then Llama models as well, which has come recently. So these are basically language models. So where you just provide the text prompt, right? And then you get the output. So that's basically, the foundation of NLP, where the data is in the form of text or audio. So these are some examples that you might have come across in your day-to-day life. So let's say you receive an email from someone saying that you have won a lottery, right? So many times, what happens is in those emails, you'll see some spelling mistakes or some special characters being used, as you can see in this example. You see this lottery, the E is a symbol of the euro, dollar, okay, euro symbol, okay, and the one is capital in this case. So how does Gmail classify this email whether this is a spam or not? Not every time you'll just go through all the emails and manually just tag it as spam or not a spam, right? So Gmail does that for you. It does machine learning in the backend. What it does is it will try to identify these special characters or spelling mistakes, or let's say a logo of a company being used incorrectly. Okay, you might have come across that meme on Facebook, right? Adidas and all those brands where you are copying an assignment from someone. So your friend says that just change the assignment so that the teacher doesn't know. So you just change the logo of that. So that's just an example for you to understand this. So that's how the Gmail classifier works. And then you have also seen these examples, right? Hate speech recognition on YouTube comments. So if you just put some, hate speech in the comment section of some YouTube videos, then YouTube automatically takes it down, tweets on X as well, that is Twitter and so on. So these are examples of supervised learning on unstructured data. So we explicitly first teach the model that you have to do those actions based on the data that you receive. Okay. So that's why we call it as supervised learning.
काइंडली ये स्क्रीन विजिबल नहीं है तो आप ये
So
स्क्रीन
now
को
let's try to
देखें.
understand this unsupervised learning. So in unsupervised learning, what we do is we just provide the data to the machine. We don't provide any labels. So I won't say that this is a mobile phone. I'll just provide this image and I'll ask the machine to understand on its own what this object is based on different types of data that I'm providing it to the machine. So in this example, you'll see some fruits, okay, and I want you to answer what differences that you see. Can someone just uncomment, unmute yourself and just tell me? So feel free to share your views or
Hello.
opinions. So there is no judging in this. Just feel free to let me know your
So can
thoughts.
you repeat the question?
So it's basically a
Just
difference
open the
if there are
chat section just in case. Okay, green and red. That's true. All right. So based on the features that the machine understands from the data, it can, cluster or categorize the data into different parts. So this cluster one is just, a representation of fruits which are red in color. Cluster two is the green in color, but it can also do based on the shapes. So this example just deals with the colors, but yeah, that's how unsupervised learning works. Uh, okay, so we just provide the data and then it categorizes or clusters the data into, based on the features that it has learned from, and that's how it does it. So I won't go in the detail of this. Okay, so yeah, now let's try to understand neural networks. So this is a great example to understand what neural network are. So I think you have like at least once in your lifetime you have touched a hot object, and as soon as you touch it, you take it off right from the object. You take your hand off to the object. So how does this work? So just a bit of science going back to fourth standard. The brain sends a signal through the neurons and activates the tissue cells that yeah, you have touched a hot object, so you have to immediately take your hand off the object. Otherwise, your hand will burn. So we get an input from the brain that the signal which is carried by the neurons. Okay, there is an activation function, okay, which tells the tissue that the object is hot. And what is the output? The output is we take the hand of the hot object. Okay, we don't just keep it like that, right? Unless we are a superhuman. So that's how neural networks also work. Uh, so neural networks are basically for computers since we are humans. These signals are carried by the neurons. But for this we have the neural network as well, right? Okay, so we have artificial neural networks in this case. Okay, so this is how this works. There is an input layer where you provide the data, okay, which carries the data from one neuron to another. The circles or the nodes that you see, these are nothing but the neurons. Okay,
Yeah.
so this is an artificial brain you can consider of a computer, okay, and it carries the data. Like this is the input layer. The middle one that you see, this is the hidden layer where all the mathematical operations happen, and then finally we get the output. So this neural network that you see, it's the most simplest example of the neural network, okay, which has three layers of this nodes. But in real world scenarios or applications that we see, there are a lot of layers, like thousands and millions and so on. So in the latest models of Gemini and Gemma, all those things that you see these days, so these are like very complex like these have very complex neural network architecture. But this is the basic fundamental of this. So we provide the data, which is denoted by x1 and x2. Then the W1, W2, and so on. The W denotations that you see, these are nothing but the weights, okay, which are carried from one neuron to another. The activation function that we talked about in the previous slide, this is nothing but the mathematical operations that is happening from one layer to another. So depending upon what kind of neural network you have built, whether it is for classification or detection, these weights are accordingly, passed from one node to another or from one layer to another, and then finally these computations happen, which gives us the output layer. So let me ask you one question based on this, if you have understood. So in this example that you see, what is my input layer and what is my output layer? Can someone tell me? Can you put in the chat? Input is the image, okay. All right. Yeah, that's fine. Can you talk about output now? Output is a classification you get, okay. Amazing. So output is the classification that we get, but how many classes? Based on how many classes do we get the output? Yeah, multi-class, that's true. But for this particular example that we saw, how many nodes do we have? Okay, Osama says five. Ramin didn't understand. Okay, all right. So let me just iterate this for you. So we provide the input image. That's pretty correct. The output that we get, it is just a single node. Okay, with five different values that you can assume. Okay, but based on the highest confidence, we just get the single as the output, right? We, you know, we get different values for this. For example, this model that we see right now, okay, it has classified this image as a Doraemon, which is 100%. So if we have five classes, then we'll have five different outputs, and based on the one which has the maximum value, that will be given as the most relevant class. So that's how this works. And now let's try to implement this in reality. So not just speaking in slides, but also let's try to implement this. So first, before that, we need to understand what is TensorFlow. So if you haven't heard about TensorFlow before, or if you haven't used this library before, then it's important that you understand what this is. So this is basically a free and open source machine learning library by the Google Brain team. It was developed back in 2015 or 2016, and it's basically an ML library where you can build ML models, train models, okay, deploy them over some applications. And the languages that it supports is Python, C++, Java, and JavaScript. So if you are more into Python, then it supports that. If you are more into C++, it supports that as well. So based upon your background or based upon the nature of your
Based upon the
working in
nature
your
of your
day-to-day
working
life,
in your
you can
day-to-day
just
life,
use
you
this
can just
library.
use this library.
The official GitHub
The
repository
official
is
GitHub
this, and you can
repository is
also
this,
check
and
out
you
the
can also
official
check out
website
the
for some
official website
examples.
for some examples.
But when we say TensorFlow, it's important to know what data we are dealing with, right? So at the end, it's just the data that we are passing from one node to another. So scalar is basically a 0D data or zero dimensional data. So when we talk about some single variable, it's a scalar. So scalar vector tensor, I think you have learned about this concept back in 11th or 12th standard. But just to, recall all those concepts, vector is basically a list, which is a one-dimensional data. Matrix is 2D. But when we talk about data which is n-dimensional, where n is nothing but greater than equal to 3, that is nothing but the tensor. And how does the name come from? So the TensorFlow is nothing but when we see this neural network, the data flows from one node to another, right? So that's how the Google Brain team had named this library TensorFlow. So basically, the data here that we deal is in the form of tensor. That's what you have to keep in mind. And yeah, so based upon the application that you're working on, if it is a standalone desktop application, that's let's say you're working with Python, then you can just use the TensorFlow format. Okay, so there are different variations of TensorFlow models. It can be just a protobuf file, or depending upon its if it's a web browser, then you use the TFJS version of TensorFlow, which is TensorFlow.js, which supports JavaScript. And let's say if you have a mobile application, an Android or a iOS application, or let's say you're working with Arduino or Raspberry Pi, right? Those IoT devices. So to run ML models on such a small device, it's not possible because it takes a lot of computations and hardware, right? But with the help of TF-Lite, with the introduction of TF-Lite models, it's lightweight in nature and it can support even on these small devices. So I think many of you have used this, Google Photos, right? So if you have observed, if you click a picture of something, let's say a mountain or something like that, or a car, then Google automatically classifies those images as a car or as a landscape or something like that, right? So what it is doing is it is just running some image classification models on your mobile phone itself. Okay. So you see, it's not communicating with any cloud or some APIs. It's all the processing is happening on your mobile phones, and that's due to these small lightweight models, which is done with the help of TF Lite. So yeah, we can deploy all these models based upon the application that we are working on. We'll see some examples, of course, to understand better. But let's try to do something practical now. Enough of theoretical knowledge. So this is an example of a simple image classification for the MNext dataset. So I'll just minimize my screen. You can just follow me along. Okay, so I'll just drop a link of the GitHub repository in the chat. I've already created a repository for you where you can get all the resources of this session. So you can just go to this repository. Okay, so have you used Google Colab anytime before? Or have you heard about Google Colab? All right, great. So we'll be doing some practical hands-on on Google Colab. Okay, so I've pasted the link in the like in the chat. for the repository. You can just clone this, or you can just download a zip of this. Okay, the first step is to log into your Gmail account, which I think we have already done. So just type in collab on your web browser and just click on the first link. And if you don't want to download the entire repository, you can just download this particular collab notebook file. So just click on this and you'll see a download button here, download raw file. You can just click this. So clicking this will only download this particular file. Okay, so I've already downloaded that on my machine. So I'll just click on this file, upload notebook, browse through this. Okay, but before that, have you heard about what is MNIST? We'll be working on MNIST image classification, but we also need to understand what exactly MNIST is. Okay, some of you have heard about that, some of you have not. So for those who haven't heard about this, it's just a data set. So if you just type in MNIST data set on Google and if you just go to the images, so this is basically a data set of handwritten digits from 0 to 9. Okay, that you see. So these images are black in color, like black background and white digits. Okay, so each image that you see, this is a 28 cross 28 pixel. Okay, the height and width of each image that you see, it's 28 cross 28. So we'll be building a classification model based on this. Okay, this is what the lab is all about. So once you have uploaded this notebook, just click on this connect button. So we connect to an instance of Google Colab. Okay, so here we go. We first import the library, which is TensorFlow. So import TensorFlow STF. So once you have connected, you should see this green tick and some RAM and disk values here. Okay, so that means that you are connected to an instance. So you can just click on this cell to run the cell. Those of you who are not in from Python background, this is how we run the Jupyter Notebook files in Google Colab. Okay, so we are importing the libraries TensorFlow, Matplotlib, and NumPy. Matplotlib is basically used to plot the images that we have. Okay, so once the cell is run, you'll see a green tick here as well. So this is specifically for those who are using Google Colab for the very first time. And yeah, once the library is loaded or imported, then you can just load the data set. So tf.keras.datasets is a built-in library or built-in data set for MNIST. Okay, you can get the data set here. So when we say that we are building a ML model, we have the data which needs to be divided into two parts. First is the train part, where we'll be using the data to train the model, and then we have also some data that needs to be tested. So that is X-test, X-train and X-test respectively. The Y-train and Y-test that you see, these are the labels for each of the images. So I know it's not clear to you, so let me just plot this for better understanding. So that's what I was, trying to explain you. So the images that you see, these are the images, okay? X train, these are the X train values, and the values that you see below them, these are the labels. So this is a 4 digit, and the label assigned to it is the digit 4, right? And so on. So for every image, we have a particular label. So this is an example of supervised learning where we are telling the machine that this is a 6. So in the next time when you see this 6, you should give this as an output. Okay, so this is how we plot the data. Then we have to build an ML model. So the layer that we were talking about, we first start with the input layer followed by some uh, hidden layers, and then finally we get the output layer. So you see the dense layer, this is nothing but the output layer, and it has value as 10. Why? Because we are dealing with 10 different classes from 0 to 9. So in the cartoon classification example, the dense layer had value 5 based on the number of classes. Then the input shape here, as I was telling you that the MNIST data set that we have, it's 28 and 28 in height and width. Okay, so that's why we have to, to specify the input shape, and these are the activation functions. So we'll be using ReLU for this. So just run the cell. It will define the model architecture for you. And we specify the the number of epochs. So if you don't specify anything, by default it will consider that 5 epochs is the number of times that you need to train the model for. So it doesn't take much time because we are dealing with a very small subset of the original data set. So you see, with each epoch, the accuracy is increasing because it is learning better from the previous epoch. Okay, just a basic example of how do you build your own machine learning model. Epoch is nothing but, if you're not aware of what exactly epoch is, let's say you have an exam, you open the notebook for the very first time, you try to understand some concept. Now let's say we have still 3 more days left for the exam. So again, you'll open the notebook tomorrow, you'll revise the concepts. If you haven't, learned something from yesterday, then you will relearn those things. Okay. If you have missed something from the subject, then you again try to, grasp those knowledge or those concepts.
Yes.
So that's how this epoch also works. So this is basically the model is revising based on the previous data that it has seen, and then it tries to improvise on that. So we fit the model on these parameters. Xtrain is nothing but the images, Ytrain is nothing but the labels assigned to each image. The number of epochs that we provide is 5. If you just provide it as 10, then it will take some longer time to train the model, but it will also, kind of increase the accuracy. But if you just specify a lot of epochs, then the model will take a really, long time to train it. So we have to choose a number which is somewhere like intermediate. It should not be too high, otherwise the model will take too much time to train. If it is too low, then the model will not learn anything. So that's how it is. And the model is trained, I think, with an accuracy of about 97%. That's pretty good accuracy. So let's say I want to test a model now. So what we can do, you can just provide an image, test image. Okay. The X test that we saw here earlier, this is nothing but the image. Okay. So we had these images reserved for testing the model. So you can just provide any image that you wish to. So X test of 45, for example, just an example, which is nothing but the 45th image or the 46th image. We start with the index 0. So this is the 46th image in the test data. Okay. I don't know what image this is, so I'll just plot this. Okay, so this is a digit 5 as it seems. Now let me just run the model on this. Let me execute this cell. So what it will do is it will try to predict what this digit is exactly. Okay. Now let's run this cell to get the label. And this is the label, which is 5, which is correct. So that's how you build your own ML model for image classification. So this is just a simple example of digits. The data that you saw is very small. It's a small image of 28 into 28, and it's a black and white image as well. Not to forget that, because the more complexity your image has, the more time it takes to learn from the features. Okay, and accordingly you have to adjust these hyperparameters, which is nothing but this epochs and optimizers and so on. But that's how it works basically. So if it's your first time, then congratulations, you have built your own ML model. You can get this collab notebook on my GitHub repository in case you want to, refer to this in the future. So that's how TensorFlow works. It does more complex things than what we saw right now. Okay, so let me just go back to the slides again. I hope this is clear to you. If you have any queries or questions, then you can just put in the chat, or you can unmute yourself, or let me know, then we can just proceed with the next concepts. Okay. Okay, so how many of you have played this GTA Vice City game in your childhood or still play this? Okay, great. So let me show you an example of computer vision. Uh, this is an example of the project that I had built few time ago. So this is real-time object detection that we are doing. It's more complex than what we saw right now. So basically, the image that you see at the left-hand side, it's a raw feed, and the right-hand side that you see, it's doing some object detection based on the characters or the objects that it sees. So you can build object detection models with TensorFlow. You can build image classification models. You can also find the repository to this project on my GitHub profile. I'll put the link in the chat. And how many of you have played this Cricket 07 or Ashes Cricket 2009 video game? So this is another example of that, of pose classification. Okay, so where I'm holding a cricket bat in my hand at the left hand side, not touching the keyboard, and it's just playing the cricket shot on its own. So it's basically running a pose classification model on this. You can also find the project uh, repository in my profile. And this is another example of object detection. So this is one example that I built recently for environment, where we can just classify and detect different types of waste right in your browser using the TFJS and TF-Lite models. So the motive of this to show you is like basically what things you can do with the help of TensorFlow. So these are some amazing projects that you can build around this. Okay, and I have an activity for you guys. I think we are already running out of time, but yeah, let's try to do this. So if you can just scan this particular QR code, then you'll be redirected to a website. So I want you to just try a text prompt on this. This is basically an example of stable diffusion. So I'll just give you 2 minutes. What you have to do is you have to scan this QR code, provide a text prompt, okay, take a screenshot of the results that you get, and then post it on Twitter or LinkedIn with the following hashtags. And then you can also mention me as well as TFUG Islamabad.
चैनल ले आइयो
Just a couple of minutes, and we can
लास्ट
proceed with the next few slides and concepts. So if you're done, then just put in the chat that you are done with this. You can just take a screenshot of this, okay, and scan through your mobile phones. All right. So don't forget to post this on Twitter or LinkedIn with the following hashtags, and don't forget to mention me as well as TFUG Islamabad. So I'm interested to see what you have given in the text prompt. But let's now just move ahead. We are running out of time. So you have heard about this Gemini, right? Gemini models. So this is just an overview of what Gemini models are. So it's basically a family of the largest multimodal AI models developed by the Google DeepMind team. It was rolled out back in December 2023, and it supports dataset in the form of like it was trained on such large dataset which is in the form of text, code, images, videos, audios, and so on. Okay. So with the help of this, you can just do a lot of more complex stuff. Okay. So Ultra is the most intelligent model among these, but the most commonly used is the Pro models. And if your use case is based on on-device deployment of Gen AI applications, then you can use this Gemini Nano model as well. Okay, this is the architecture. I'll just skip this for now, but if you want to have the overview, I'll just share the slides with you. But let me just quickly explain this in short. So let's say you have a data. It can either be in the form of text or a code or a image. So irrespective of what kind of data you're dealing with, Gemini can handle all these data. It passes this to the mixture of experts, which is MOE. What it does is based on the data it receives, it will give the it will pass it to the decoder, and the decoder will give the outputs accordingly. So in the earlier example that we saw, the image classification object detection, the neural networks were trained specifically only for images and videos. So if you provide any text data, it won't work in that case, right? So this is how the Gemini model was trained on. It works with all such data sets. And This is a quick hands-on of Gemini 1.0 Pro. You can also find the collab notebook in the repository that I shared. I'll just quickly open it. So if it is new for you, if these Gemini models are new for you, then let me just show you how you can use this. Okay, so the first step is to open Google AI Studio. This is basically where you can get the API key. I've already created an API key for myself, so I won't be doing that step again, but just to show you quickly, you have to go to this aistudio.google.com. You can just create an API key for yourself here by clicking on this get API key. So, okay, let me just connect to this instance. So these are the models available to be used through the Gemini API. We have Gemini 1.0 Pro, Pro latest, and so on. We'll be using the last two ones. The Gemini Pro model, which deals with the data in the form of text. So this is an example prompt that I provide. Suggest some best places to visit in India. So just configure the model that you want to use. So in this case, it is Gemini Pro, the prompt that you give. So if you are dealing with let's say some code, you want to generate some code, so you can just provide the prompt accordingly. So this is just an example to show you. Okay, so probably something is going wrong in my prompt, that it has it says that there is an invalid part in my prompt. If there is some safety say ratings, like it's identifying the prompt as some incorrect thing. Okay, I'll need to check this, but we are running out of time right now. So this is how it works based on the prompt, whether it is hate speech, whether it is dangerous content. I don't think there is anything dangerous in this, but it has gone wrong for now. Let's try to give some another prompt. Mm, let me just change this to this. All right. So these are some historical sites to visit in Islamabad. I think some you know places, shopping centers, and so on. You can also deal with images. So we have to use the Gemini Pro Vision model in that case. So I won't be running this because it will take some time. So what you have to do is not only just pass the prompt but also the image. So this is a image of one of the regions in Ladakh. Okay. So this is the Pangong Lake there. So I have given the image and asked the model to identify the place from the image. So it tries to understand what the image we have provided and accordingly it gives a response. So that's how you can play around with the Gemini models. And yeah, it's available on my GitHub repository, so feel free to try this. Let me show you some quick examples that we have built with Gemini. So this is PharmaScan, one of the examples that we built, okay, with one of the fellow GDs. So PharmaScan is basically an Android application where you just upload the picture of a medicine. Let's say you don't have the background or knowledge of what this medicine is used for. So instead of you going to Google and or going to a chemist or a doctor and asking him what this is used for, you just upload the image and you get all the details like the dosage, usage, and diagnosis of the medicines, when to use this, when not to use, and so on. So it's again available on my GitHub repository. Feel free to check this. If you like the project, then don't hesitate in giving it a star. Then, yeah, this project was also featured on the official handle of the Google Developer Expert. So that was a pretty great achievement for us. And we also built this another example called as farm scan. So it's similar to farmer scan. Just upload a picture of the fruit or the crop, and you get all the details like the freshness of these fruits and vegetables, and approximate market value, and so on. And then we also build this Gemma model, like Gemma based application for on-device deployment. So these projects are available there. And yeah, so these are some resources for you to get started with Gemini. Okay, so if you're a newbie in Gemini and LLMs and all those stuff, you can get started with this by understanding what is Gemini model, how you can use it directly in your Google AI Studio without doing any coding or without doing anything. Okay, so it's just a low code or no code platform. You can just upload the images and prompt, and you'll get all the outputs. Similarly, if you are into Python or JavaScript or any other programming language, you have some SDKs as well to get started with. And yeah, so I think we rest at the end of this session due to time constraint, but that was the overview of this particular session. I hope you liked it. I hope you liked the examples that we covered. If you have any queries or questions, feel free to reach out to me on LinkedIn by scanning this QR code. I'll also put in the chat. You can also follow me on my Medium handle to stay updated with the blogs that I write. And you can also follow me on Twitter as well as GitHub, to check the project that I built. So thank you so much, TFUG Islamabad team and Ali for inviting me. I hope it was a. I'll just repeat what we have learned in this analyst data set. Classification example. So let me share my screen. Okay, is it visible?
Yes, sir.
Okay, so we started with the loading of the libraries, which is TensorFlow and this. And what we do is we just load the data set. It's already available as a as a submodule in Keras. So tf.keras.datasets.mnist. What it does is it will load the dataset for you, and it's already divided into two parts: the training part and the test part. So we just load the dataset into that, and this divide by 255 that you see, this is basically to normalize the image. So when we talk about images, these are in the form of RGB pixels, right? Red, green, and blue channels. So dividing that, what it will do is it will just scale the numbers between 0 and 1. So if you see what 0 is, 0 pixels is nothing but completely black image, and the one that you see is completely white image, and whatever is between 0 and 1, that's the gray part of that. So this will have 0 value, this will have 1 value depending upon the brighter side of the image, and the gray values that you see, it's intermediate, like that is between 0 and 1. So if it is too close to 0, then it's darker side of the pixel. If it is too close to the 1, that's the brighter side of the image. So once the model is once the data is loaded, we build the Keras sequential model in this. So basically, sequential is nothing but we create layers one after the other. So that's why we call it as a Keras sequential model. We start with the first layer, which is the input layer that we pass to the model. Okay, so that is nothing but we resize the image into the input shape of 28 and 28, because the data set that we had, it's of the height 28 and width 28. So depending upon what image you are dealing with, you have to accordingly resize this. Then there is a dense layer, okay, and the activation layer that we are talking about here is ReLU. You can just learn more about this ReLU layer. And then we use this dropout layer. So dropout layer is basically to prevent overfitting. Overfitting is nothing but, let's say you have trained the model on a set of data, so it's trained perfectly well, but when you test that model, it's overfitting. Overfitting is nothing but it's giving results which are not much accurate than what you had expected. So we use a dropout layer for that. And then the dense layer is nothing but the output layer. So we had 10 classes, that is digits from 0 to 9. So we use this and then we train the model for that. The softmax function that you see, it gives the predictions, and based on the predictions, like we have 10 different predictions, right, from 0 to 9. So the most highest prediction that we get, that is displayed on the screen. So that's what softmax does for you. I think I've closed the collab file, but you can just check it again. So you'll see that the most relevant class or label it has found, it will give you the result based on that. So that's an example of this overall, like overview of this amnesty index classification example. Okay, I hope that was clear to you. If you want me to
Yes,
repeat
thank you.
anything else, then let me
No,
know.
it's
There is a question from Fatima which says that you are intermediate in C++, interested in ML and LLM. Would you recommend switching to Python? Okay. So, like, people are still using LLMs with C++. I don't know what exactly they do with that. I mean, like, you can build libraries based on that, but the most commonly used programming language for machine learning and LLMs is Python itself. So you can just, keep on working with C++, but also try to, get started with Python as well. So if you are more into ML and LLMs, if you want to pursue your career based on that, then Python is the most widely used language for that. Can we build career in just NLP? There is no definite, answer to this because we really don't know what the future is about. So, if you talk about, 5 years before what it is currently, the computer vision was more in, in the buzz. So now recently the generative AI and all those NLP and LM stuff has taken. So we really don't know what exactly we are heading towards, but currently it's in boom right now. So NLP is highly used in many companies as well as, many industries. So that can be a good path, but it's better that we also explore, other fields as well and not just stick to just one particular domain or field. Okay. Okay, so if you want to pursue ML, the first and foremost thing that I always, tell people that start from the basics, try to learn the fundamentals and the, algorithms that we have right from the basics. Don't just, go to advanced topics like NLP and LLMs. First, try to understand the simple, algorithms, how you can use image classification, how you can, build a linear regression model and so on. So for you, you can just get started with a deep learning.ai course on Coursera, which is offered by Stanford University, where you get, in-depth knowledge of how you can use ML models, which algorithms to be used, which one not to be used, and so on. And after that, you can just take a step ahead and go to further, complex topics like neural networks, deep learning, then computer vision, NLP, and so on. So I would recommend, take baby steps on that and try to learn things based on that, and don't just learn things, but also implement projects based on your learning. So that's the best way to, learn machine learning, and make sure that you create projects based on your learning, make it open on GitHub repository so that, it can reach to a wider audience as well. So make sure that keep your repositories open, and yeah, that's what I would suggest. Okay. So if you want to find tune LLMs, you can just go to Hugging Face where you will get a lot of references like notebooks or tutorials or blogs where you can just fine tune LLMs. I'll just drop a link of one of the projects that I did to have some reference. Okay, so if you have used Gemma models, then you can also fine tune it. I'll just drop a link of that project. So you can go through this. It not only teaches you how to fine tune a Gemma model, but also deploy it on an Android device so that you can just use that, Gemma language model right on your mobile phone without doing any kind of API communications that we were doing. So that could be one of the best resources to get started. I've covered everything in this, right from end to end, like how do you prepare your own data set, then fine tuning it, and then deploying it. And yeah, so if you're also looking for fine tuning a vision language model, not just a language model, then you can also check this one. So this particular repository helps you find in a vision language model, which is the IDFX2 dataset on, IDFX2 model on Hugging Face, which was developed by the Hugging Face team, where you can play around with image text pair dataset and fine tune your own model on that. Okay, any other questions or queries? Okay, Ali says that we have to learn the code step by step, or we just need to get the abstract idea. See, the most important thing to understand is you know the concepts that we are dealing with. Okay, so it's not just about building projects. The first foremost thing that I always recommend is try to understand what is happening behind the code. Okay, so once you understand the motive of why this code is written, what is the purpose, then you can just replicate that. You can just try to build your own projects around that. If you have any ideas, let's say if there is some open source projects, you can just take that as a reference, as a starting point, and if you have any ideas, then you can just customize it based on your solution or based on your ideas, and accordingly you can then just build things around that. Dataset is basically the data that we talk about. So of course, when we are dealing with machine learning or something like that, it's all about data. So if you don't have any data, forget about training the models. So dataset is nothing but the data that we have. It can be images or videos or text data, anything, depending upon what you are solving. Okay, how we can access data practice is now good in machine learning. See, no one is an expert. I'll never call myself as an expert because I'm still learning ML. It's a very vast field, so you can never call yourself that you're good enough in ML. But one thing that you can gauge yourself on is if you have built some projects and if you have built, like, if you're confident in something, then try to publish your works on social media platforms where people can reach out to you. Okay, so if they feel that your work is pretty much commendable, then I think you'll get opportunities from the front itself. So just keep on doing stuff, keep on learning new things, and I think things will fall in place accordingly. Okay. I think the most important thing is you have to understand coding first. Forget about machine learning or TensorFlow. Okay, so if you are good enough in Python, I don't want you to be, expert or professional, but if you just understand the simple things like what is a for loop or what this particular is doing in the, in my code base. So try to understand the reason behind that. Then, you know, cover the basics first. Don't just jump on prompt engineering or LLMs. Otherwise, you'll miss a lot of stuff. So these LLMs, what we see right now, these are based on the transformers models, okay, transformer architecture, which was released by Google. So to understand transformers, you need to understand NLP. To understand NLP, you need to understand the basics of machine learning. So again, it goes in the loop. So start from the fundamentals so that you don't face any difficulties or problems when you work on some complex stuff. Of course, we can use prompt engineering to solve some particular task, but if you want to pursue a career in that, then make sure that you brush up your foundations so that it will be easier for you in your path. Okay, what size of project in ML we need to do in practice? Size of project as in sense, see, there is no big or small project. So let's say if you have come across any problem that can be solved with computer vision. So just take it as an opportunity and try to implement the ideas or the understanding that you have gained from learning these things. Okay, so it need not be very big or it need not be very complex. Just take just start with a small idea. Okay, try to implement things based on your learning and share it in your network. That's the best way to learn things so that you can also get ideas from other people. So if you share things with them, you'll get some feedback that this needs to be adjusted or improved, and you'll also have opportunities to collaborate with other developers in the community who are also seeking people like you. So I think that would be the best way to get started. Okay, to learn the CNNs, you can just go to deeplearning.ai course on Coursera, and everything is covered in that. So the deep learning specialization covers everything, right from neural networks to CNNs and more complex networks. Okay, so that's the best way to learn. We'll also have some YouTube tutorials and documentations available on TensorFlow as well as Kera's websites. But if you want to, gain hands-on along with the theoretical knowledge, then just enroll to that course. Yeah, so it also covers some hands-on labs in the deeplearning.ai course available on Coursera, where you'll be, implementing CNN right from scratch. So once you have gained that knowledge, then you build CNNs using libraries like TensorFlow and Keras. I'll just put in the chat for your reference. Deep learning dot AI specialization. Deep learning specialization by deep learning dot AI on Coursera. You can just check this out. Okay, so if we have any further queries or questions, then let me know. Otherwise, we are good to close the call. If you have anything to share with, you can reach out to me on LinkedIn. Put in the chat for you. We can connect offline. Yeah, so once you have acquainted yourself with the theoretical concepts, there is no practical projects as such as you are saying, Zoe. So you can get started with examples available, okay, on Hugging Face as well. You can check my GitHub repository, take that as a starting point, and try to implement something similar based on that. So you just customize the solution and use your own data set to build your own models and just try to build end-to-end things. So not just training the model, but also try to deploy it somewhere so that people can use. So if I'm from a non-technical background, I don't know what is machine learning, right? All I know is how to use this application. So think from that perspective that you are building an end-to-end solution so that everyone can use. Hugging Face is basically a website you can say or a platform for ML developers where you can get a lot of machine learning models, open models, okay, which you can play around with. You'll have tutorials and examples for different use cases, different examples for LLMs, for computer vision, classification, and so on. So it's good website where you can have a lot of resources to learn and to collaborate with fellow developers in the community as well as if you want to build something, some project, then you can take that as a reference. It's just like what we do in Kaggle. See, if you are from a non-technical background and you are doing data science, all I would suggest is make your concepts clear. Uh, I won't give any, particular answer to this that you should pursue or you should not. If you are familiar with that and if data science or if machine learning interests you, then proceed with that. Don't go with the buzz that you hear in social media that this is a booming field right now. Okay. So it all depends upon your interest. So if ML is your passion, then go ahead with that. If you want to solve problems based on that. But the foremost thing you need to understand is you should have at least the basic knowledge of programming. So that is the basic thing. So even if you try to pursue ML and AI, all those stuff, you should have this at least the basic understanding of how to write a simple small piece of code. So of course, Gemini is booming right now because of the LLMs. We'll see more interesting things coming in the future as well. We have VLMs right now, vision language models, large language models which are supported on mobile phones as well. So when we say these are large language models, these are very big models about 20 GBs, 30 GBs in size. So it's now possible to run these models on small devices as well. So yeah, many companies and industries are moving towards that. So you can just check some of the open models. Gemini is an open model. You can customize it, fine tune it on your own data set to explore more things. How do I integrate ML models in my surveillance system? You can use TF Lite models for that. So there are two ways. Like you can also host your ML model on Google Cloud and do inferencing based on that. Otherwise, you can also go ahead with the on-device deployment of the models. You can you'll find some tutorials how to integrate this. I haven't done that with any surveillance system before, but there are many tutorials available that will guide you to achieve that. Gen is not only about giving prompts to LLM, it's also about, let's say, I think we talked about one of the example where I asked you to give a prompt and share a screenshot of the result, right? So that was an example of stable diffusion or nothing but image generation, where we are not only dealing with LLMs but also vision models. So stable diffusion is an example of generating images from the text prompt that we give. So overall, that's how it works. But there's a lot of more complex things happening in the background. So we can just, explore more on that. And okay, deep learning specialization is lengthy. I haven't completed. Is it worth doing? See, things will be complex, but you have to go through that. Okay, so if you are really interested in learning ML, then you have to spend some time to understand the code, to understand the topics. Okay, so if you skip that, then a lot of things will be skipped, of course. So make sure that you take small steps. You don't need to, complete the course or the specialization in 1 day or 1 week. Take your own time. Try to understand stuff based on the learnings or the videos given in the course, and then you know, build projects around that, small projects, and then you will find interest in that. So you won't find it boring. And yeah, that's what I will suggest. Practically performing it. So basically, take some real world scenarios that happen around you. Okay, take that as a problem statement to solve. So once you have learned something, there are plenty of tutorials available to do a particular task. So the GTA Vice City example that I showed in the presentation. So no one had done object detection on a video game anytime before. I mean, people might have done, but I haven't seen that. So I took an example of the example available on the TensorFlow official website, and then I customize it based on what I wanted to achieve. You can just take that as a reference point, okay, where you can practically implement the things that you learn. So that's what you can do. Okay, so you can reach out to the TFUG Islamabad team for different communities. Okay, I don't know like which communities running in Pakistan right now, but there are a lot of communities running in India for different, different people, different backgrounds. Let's say for machine learning enthusiasts, this is TFUG. We have other communities as well running GDGs as well. So you can just go to the official website of GDGs and get a list of the communities running in your country, and you can reach out to them. Okay, then I think that's all. If you have any further queries or questions, then you can, of course, reach out to me on LinkedIn. I'll be glad to answer your queries or questions. So I hope you enjoyed the session and get some valuable insights on how do you use ML, how do you get started with machine learning, and how you can, build projects around that. So thank you so much again, TFAG Islamabad team, for inviting me. We'll meet again, hopefully. So have a great day. Bye. Thanks.